That again, please.
My name is Mark Williams. I work for Monroe. Thank you for purchasing our products. We're here for you if you need anything.
We use Manuel Hernandez from Valley Growers Landscape. I'm the foreman for the irrigation control. Wonderful. Perfect.
Pedro Gonzalez, field supervisor of the landscape project, and basically checking that everything works properly.
Perfect. You guys want to introduce yourselves, just so we can?
Sure. Jamie Hurd. I'm one of the project managers at Grant High School.
Stetson Jans, Facilities Operations Manager.
Bryce Gardner, Construction Manager, PPS.
Tim Curtin, Heck Story Grant.
Oh, sorry, Lindsay.
Dave Donnekamp, plumber with PPS.
Perfect.
Yeah, Mark Franklin with the Landscape, Portland Schools.
Gary Hunter with the Landscape, Portland Schools.
Okay, and this is
Mark Williams from Monroe.
So Q&A means questions and answers, and questions is you guys' job, answers is mine.
Yes, sir. Okay, what are we looking at? What is this thing?
This is a pump station. We call it simplex because it has one motor, one pump, and it is rated at 90 psi boost at 90 gallons a minute with 50 psi coming in. These details are on a sticker here on the side. I will leave my contact information on the station. This will be my cell phone number. If you have any questions, you can call me. I have all this information online as well.
Does this control all the irrigation of the whole project?
Yes. Well, that's not a good question for me, actually.
That is a correct statement, yes. There's a irrigation controller in here also. That is a temporary irrigation controller just for us for planting. The manufacturer is getting us a permanent controller on the 25th, which is so we can start to seed. The temporary controller does not affect the installation of the permanent controller.
But will the permanent one be in this
No,
box?
sir.
Okay.
The permanent controller will be in the emergency electrical room in the basement of the auditorium.
And that is what creates, it synthesizes power for the motor so the motor can drive the pump at variable speeds. I'll try to keep it simple for you. Essentially, we tell it what pressure to run. It has a device called a transducer over here where it senses what the pressure is at the time, and then it speeds up or slows down the pump in order to maintain that pressure, kind of like your cruise control in your car. Right? Set your cruise control at 70 miles an hour. If it starts going too fast, it backs off the gas. If it starts going too slow, it speeds up. Right? So let's see. So we have basically the cabinet. We have the control panel where all of our wires and connections are made. We have a disconnect over here. We have a pump. We have a check valve. We have an inlet gauge, a discharge gauge, and a couple of isolation valves. The fans are for keeping the panel, the pump house from getting too hot. There are filters on the fans that'll have to be maintained. We're going to cover that a little bit when we do the when we go through the video. Do you want to switch to the other side so we can all know what we're talking about on the?
Let's do it.
So these doors, if you need, they can come off. What we're doing here is generally a very bad idea. You'll notice I have the cones backing up the doors. The problem is this big door, if the wind catches this big door against this little fulcrum right here, it'll rip these hinges right off of here. So I generally recommend you keep one side closed at a time. Prevents flow through, which will help. If it's breezy outside and you have to be working on it, I recommend you lift the doors off the pins and set them on the ground someplace and make sure they don't fly away. So this is your motor, this is your pump, this is your check valve, this is your transducer, this is somebody's cute pair of glasses. So water comes in on this side. There's a backflow preventer down here in this vault. You can isolate down there. There's a valve behind here that you can't quite see that you can isolate there. You can isolate here. So that's suction side gauge. This is the discharge side gauge. So when this is running, our set point's 90 psi. This should be at about 90 psi. Sometimes it takes it a minute. We have it operating, accelerating very slowly so that you don't get some hard hits on your pipes. So it'll start out being low when you first turn things on. It'll creep its way up, and then it's going to pass your set point, and it's going to start slowing back down, and the pressure will start dropping again, and then it'll settle down when it gets to 90. We could make it track more accurately, but by making it track more accurately, make it respond more quickly. When I respond more quickly, it means we change pressures in your field more quickly, which is hard on your pipes. So we sacrifice a little extra pressure for less of a hard hit. This is what we call a vertical pump stack. There are several impellers in the middle of this. Each impeller progressively makes more pressure. One feeds the next stage. Each stage makes more pressure. So this pump will make a lot of pressure. This pump will make 140 psi out of 30 psi. It's a 5 horsepower motor. There's a really important function on this. This is a bleeder valve. Anytime you think there's been an interruption in your water, you need to open that valve. Really wasn't prepared for this. I'm sorry. I should have kept my channel locks out. This does not have to be tight. It doesn't take much to loosen it. It's a needle valve. You see it leaking water? You just want to make sure it leaks water and not air. So anytime you think you might have had air in there, you need to do that. There's a mechanical seal right here is what keeps this from leaking water. And since air tends to go to the top, any air bubbles are going to want to get stuck at the top of this. If that mechanical seal, it requires water for lubrication. So people say, how often should I check it? I tell them every time you're out here. If you got the door open, you should probably check it. It only takes a second, right? And the cost, that cartridge seal is probably $500.
Does that tell you on the other side that you've lost suction?
It does not, unless you go into loss of prime.
Okay, it will tell.
So if you go into loss of prime fault, it will, yes.
It will tell.
But if you have something, like say you know you're going to be working on your backflow preventers once a year to maintain them, you're going to shut the water off. Hopefully you're going to shut the pump station off as well. You're going to open up your backflow preventer. You're going to put air into your system. You're going to do all your adjustments on the backflow preventer. You're going to close it back up, and you're going to push that air bubble down here to this. You won't have any faults, but you'll have a big air bubble right here. That's a scenario where I can envision where that you might have a problem with that. This is a needle. You don't need to tighten it real tight. So these gauges are here because those are your friends. Those are really going to tell you. When we were just doing the startup over here, we noticed we were trying to run these smaller zones. We were actually below zero. That's zero. We were in the vacuum side, so we knew we had a problem. There was a lack of water. And so that's useful information to know when you're trying to troubleshoot, find out why your pump station is not working very well. These gauges, we're going to talk about this a little bit. The gauges in this transducer they have a vulnerability to freezing temperatures. The gauges have a brass tube in them that expands with water pressure, so it's got water in it. If that freezes, it stretches that metal, and it'll make it start reading pressure when there's no pressure. So when we winterize, we're going to take those gauges out. This transducer is actually a crystal. It changes its resistance according to pressure, and that being a crystal is susceptible to shocks, temperature shocks. When I say shocks, I mean like you can't drop it. Dropping it might break it. And you'll have to take that inside and keep that warm in the wintertime as well. Now, in the process of taking it out, I left the cover off over there. You're going to disconnect it. You're going to unthread it. You're not going to unthread it here because if you do that, that's going to short the wires inside, and then it'll be bad as well. So you're going to unthread the whole device. We've talked about this, about how you're going to winterize, and you're probably going to pull one of these gauges out. You're going to take the other one out. You can take the transducer out. You can blow it out with compressed air and blow out your whole field. And then you're going to pull the.
You can't do it with them in.
Can't do.
Blow it with air.
You can.
But then would you still have to remove them for winter then?
I would recommend it. You know, if it's a small port in there, if it still has water in it and it freezes, you know, who knows, it might break it.
We have one other system like this, but it's inside a heated room.
Yeah, see, if you, that's another possibility too. You could bring a heater out here, but then if you have a power failure, it's going to be catastrophic. So whatever your preferred method, and then you're going to be pumping the water out of your lines on the ground anyway, right? So may as well do it all. There's a drain plug right about here on the other side that you'll also pull. That'll drain this canister right here, so that's not full of water. And there's grease zerks on here that we're going to talk about greasing with your maintenance. You're going to do that at least twice a year probably, just 2 or 3 squirts. You've got air filters in here that you're going to clean. So any questions? Remember, this is question and answer.
Shut off to this system in the hole.
It depends on what you want to do.
Does something different
Right.
than how you shut it down?
It's a valid question. So, I mean, you know, that may not be the easiest thing to get into. That's a very good question. If you don't have your keys, this might not be the easiest thing to get into. But if you have a set of keys, hopefully you have a set of keys, I would just get in here and close one of these. You know, this would be the easiest one to get to. If you do that, there's no water leaving the station going out that way. So that's.
If this system's taken out, then you want to shut it off in the hole. If
So
somebody comes and gets to the car,
there's multiple shutoffs here. We
Yeah.
have the screw shutoff here in the backflow preventer, and then we have a gate valve about where that yellow flag is there with another cap on it. The gate valve comes off of a T off the main line for the domestic water. And then as you follow that back in front of the monument wall at the main entrance, there's also another backflow preventer there inside of a vault that can be shut off, and then it's just adjacent to, just east of that is the main water meter for the site.
Now, during the maintenance section of the video that we're going to do next, I'm going to talk about type EM grease. EM stands for electric motor. There's a million different manufacturers of grease out there. I can't tell you which ones are going to be compatible with EM grease and which ones aren't. You can call your grease manufacturer. There's always a phone number on your tube of grease and ask them if it's compatible. Most of the synthetic stuff, GI stuff that's available nowadays is going to be compatible and work fine. But I can't take responsibility for your decision on that. You have to decide that yourself.
Compatible with what?
Type EM grease is what it comes with, which is usually a blue grease. And as far as I know, just about all electric motor manufacturers use it.
Any other Q&A before we actually make the real concise video?
yeah,
Both
I
of
got
these
a
are going to be fun.
So what activates the pump? Is it pressure on this side? Is it on demand, or is it the controller turning on the pump, opening a master valve?
That is a great question. Thank you for making sure we didn't miss that. Yeah. So there are options. We've discussed that as a possibility out here. How do we want to start and stop this? And if you use what we call relay start, where your clock actually turns the pump on and off, the advantage of that, of course, is that you don't have to run the pump when you don't want to. You can run your drifts, your MP rotators, whatever off your city water pressure and not run the pump. So that works great as long as you have some pressure. As long as you don't need pressure for quick connectors. Or
Can we get a clarification on that? If we're running a very small zone or a drip system, are you saying that the pump could be powered off and that drip zone or small sprinkler head zone would probably work just fine, the water would just flow right through?
if you chose to use a relay start, that would work. We did not choose to do a relay start because the clock for this is going to be in the basement, and it's going to be a long haul to get it out here. And then we would probably be able to connect it to the same 2-wire, but that would require more components. And so what we've elected to do, which is easily selectable with this station, is we're going to do pressure start, speed stop. Right? I don't have a flow meter on here, so it's not flow start, flow stop. So basically what it is anytime the pressure drops below whatever value I set it at, it's going to start the pump. And anytime the speed of the pump drops below what I set that at, the pump is going to go to sleep. Okay? The idea that we're going to work with here, at least temporarily, is we're going to have the start pressure be below what the incoming pressure is. So if something small comes on, it might start the pump, but the pump's going to come up to 90 psi. It's going to see that there's not much flow. It's going to see that it's not running fast enough to stay awake, and it's going to go to sleep. And when it does that, the pressure will drop back down, and it won't drop long enough or low enough for it to start the pump again. Follow me? If you have a low flow. If you have a big flow, like when we tested this on here with these rotors out here, it has to run pretty fast to keep our set point. And so it sees that it's above the speed that we've set, and it's going to just stay running. It won't turn off. So it's not quite as efficient, because sometimes you're going to be doing a start when you don't actually need the pump, but it won't run for very long. It's got a 20-second delay on it. Anytime if you had like a couple of people watering with quick connects, wanting a lot of demand, the pump, if they drop the pressure enough, the pump will start, and it'll continue to run as long as they need that pressure. So that's kind of an advantage. One of the disadvantages to calling for relay start from your clock is if your clock calls for a zone. Let's say someone was out here and they noticed that there's a broken line and they close the isolation valve out there. Well, the clock doesn't know that. The clock says go run that zone. So it tells the pump to run. The zone is closed off. Now I got a pump running against a deadhead. It doesn't take very long, and a deadhead, so you all know, just means that there's no water going anywhere. And if we were to churn this water to make 90 psi and not have any water go anywhere, but eventually what happens is that water raises in temperature, and it doesn't take this long. We're talking like within a couple of minutes, the water can turn to steam. It can actually get that hot. I've seen it melt PVC, and it does damage, and it can take out that mechanical seal. So that's one of the disadvantages to doing that way. So if you have a relay start and your irrigation clock actually has an idea of the flows, then it will see that there's no flow going, and it'll switch to the next zone, which takes care of that. But at the moment we're not doing that. We're just doing the pressure start, pressure stop, speed stop. So we use this all the time. This works. We shouldn't have any problems as long as your incoming pressure stays the same. If your incoming pressure fluctuates a lot, we may have to make some adjustments. If there's any adjustments to be made, I'm sure we'll encounter them in the first 2 years. Pedro's got my number. He's going to give me a call, and we're going to make a few adjustments.
How loud is this? Our other one sounds like a jet taking off.
It sounds a little bit like that.
Oh, okay. So most of the time it's going to be calling for it in the middle of the night. Has this been turned on with metal?
You know what?
I'm just curious if it's been at night with the box so that the neighbors have heard it.
That's it?
Well, I didn't let her run up to speed.
Oh.
Did you want me to? Yeah, it would be, huh?
Did the box have any soundproofing?
This does not. It's something that could have been ordered. We do that. We put a foam insulation that makes it real quiet. But it's not too bad. You know, we can...
We can turn the zone on and try it. Yeah. Pedro, you want to turn? Manuel, you want to turn the zone on?
Yeah, sure.
Okay.
We can try it with the doors closed as well. Any idea what percent that's running right now?
When I did this test before, it was running at, I think it was like 50 hertz out of 60.
That's a lot more.
When you heard it speed up to begin with, it probably got close to full speed. You notice it sped up and then it dropped back down again?
Will the high pitch board kind of die down after it gets going? Is that just a startup sound?
Well, that's it going up to it's like going up to 60 hertz. It went up to full speed and then it started backing down. And this is with the bigger zone. So it's, I don't know how many decibels that is, but it's not a lot. Two, three, 4, 5, 6, 7.
Yes. Yeah. Well, that's when it's going to come on. Running noises. I assume.
Probably, right?
Yeah. 1 or 2 in the morning.
If it's a problem, you can get foam from Home Depot, a spray foam.
That's what I was wondering. Some kind of foam or something.
It works surprisingly well.
I see you got vents on it, and you said something about filters.
Yeah, we do have. Yeah.
Vents.
Yeah.
Okay.
Maybe we'll have some extra of that F sword. You can glue to the inside of it. It's on the other side. Do they ever need to press the button? And if so, what do the buttons do?
Okay. Good question. There's actually not a lot. There is a keypad, and the keypad does have some buttons on it, and we could spend some time talking about what to do with that. But the thing is once we set this, you really shouldn't have to adjust them. I recommend that if you're going to play with any of those buttons, there's 1,000 parameters in there. So I do this every day, all day long. Call me. You know, let's talk about what changes you want to make, why you want to change them. You know, as long as your infrastructure stays the same, your incoming pressure stays the same, and your use for it stays the same, you should never have to change this. I run into this question all the time in the field. They're like, well, it worked last year, but it's not working this year. And usually the reason it's not working this year is because you decided you had to change something. And the fact of the matter is if you haven't changed anything out in the field, you shouldn't change anything with the pump.
Does it need any kind of a
there might be, and if there's a fault, and we're going to cover that with this thing. But I will tell you that there's a toggle switch on the face of that thing, and then there's a volume a rheostat on it, potentiometer. One's the speed control, and the other one's what we call the HOA, stands for hand, off, and auto. And that's how you're going to turn it on. If you need to run it in hand, you're going to turn it off. That's how you flip it into auto. If you have a fault, we keep track of the details of what happened on the last fault only. So if you have a fault and you know you created it, put the toggle switch in the off position, hit the reset button, and then go back to auto, and it should work. If you're not sure, you can flip it to hand. If it works in hand, then you don't have a fault. Another thing is when it's at rest, we call it sleep. It'll say sleep on the display, but the alarm will flash. I get a lot of calls about that flashing alarm. My station has got a problem. I have a flashing alarm. It says sleep alarm. The reason they do that, and as far as I know all VFD manufacturers do that, is because the pump already has a run signal. So it's not going to stop and give you any kind of a notification when it starts. It's just going to start. And so the alarm is, keep your fingers out. Be careful. It's going to start. It's going to start on its own whenever start conditions are met. So that's a normal alarm. Any other time if that alarm light is flashing, you have an alarm. It keeps
in sleep and it's flashing. That's just saying it could wake up in an automated manner, and you lose your finger.
Right. So just keep clear. Now the drive will keep track of the last 10 faults and the hours of the fault. Unfortunately, it's counting the hours of a run command. And since we're using pressure start and sleep stop, it will always have a run command. So if you see that the drive has 1,000 hours and the fault occurred at 999 hours ago, then you know the fault occurred 1 hour ago. So, you can't extrapolate that from there. But it doesn't keep any details, like it doesn't keep track of how many amps it was drawing, it doesn't keep track of how fast it was running, it doesn't keep track of the DC bus voltage. All of that is only with the last fault. So if you're not sure, it helps to just give me a call. We'll go through, we'll check those, we'll see what happened, we'll figure out what happened, why it happened, and then we'll reset it.
Perfect. All right, well, let's start the next portion then.
Okay.
So you work for
Monroe?
And so with the package deal that we bought for this pump, the services as far as calling Monroe for troubleshooting, things like that, how long does that period go on? Is it indefinitely?
That is indefinite. I'm available all the time.
Okay.
Now, bear in mind, I'm covering the entire country at the moment by myself. So, like, I've got people who've been trying to call me while I've been doing the startup, and I'm telling them, you're just going to have to wait, you know. So, you know, if you call me and you're on site and it's time, it's only going to take you a minute or something like that, you can send me a text. That phone number is my cell phone. Send me a text. Leave me a message. I'll tell you, usually the first thing I do when I get freed up after I'm tied up, something like this, is I go and I answer all my voicemails.
Yep.
So that gets, sometimes if I get time, like right now, clearly I can't be checking my texts, but if I have a moment, like sometimes, like we were out there waiting, we're watering out there and testing things. In the meantime, I manage to take another call. If I can, I'll try to help you there. Otherwise, you can always email me, schedule it. I work Monday through Friday. I tend to work 10 hours a day, and it tends to be, who knows what time of year it is, right? I might be on the East Coast, I might be on the West Coast. I travel a lot. I might be in the air. So.
Well, thank you for coming out.
You bet.
Yeah. So if ever in the future, I understand that you come out one time for the commissioning of the pump. Ever in the future, once we turn this over to the PPS, what does that look like for you to come back out for this pump? Is that a possibility?
It is.
Obviously, I imagine there's some form of payment that has to be made to your company.
It is a possibility. We get $150 an hour, plus travel expenses, motel fees, whatever. Part of my job is to find service providers who do this for a living, you know, for either build their own pump stations or they do maintenance, they do repairs on pump stations in general. And I'm building a map of those. And so you can call me and I can refer you to someone, give you a phone number and say, call this guy. He can come. That'll be the cheaper option for you.
Sure.
And usually I get them signed up with me and I get all their credit information and everything, and I consider them a service provider for us. And then I give him all the support I can offer him. And I rely on him to let me know if it's a warranty situation, and if it's a warranty situation, then I'll pay him. Just so you guys know ahead of time. Even if we're pretty sure it's a warranty situation, he's going to ask you for your credit information to make sure you have that arranged, because it's a lot easier to make sure you're getting paid up front than after you've solved the problem and now you're trying to collect. So I always warn them that I'm not in the collection business. They have to get that from you first, and then we'll rely on their expertise to let us know if it was a warranty situation or not. Now, the warranty is against manufacturing defects, materials, workmanship. So one of the things that we talked about a little bit earlier was maintenance. You know, if you buy a new vehicle, you're expected to do oil changes, you're expected to do maintenance. Well, I have the same requirements with this. I need the motor to be greased occasionally, I need to have the electrical connections tightened up occasionally, and I expect you to do your part. But like, for example, this mechanical seal, it's not leaking right now. If the mechanical seal starts leaking next year, why would I think that's a defective mechanical seal? It's most likely going to be something happened out in the field that caused it to fail.
Is there going to be like a written checklist inside?
For
maintenance?
Yes.
Sit down?
Yes, that's the next section, actually, yes.
So there will be something?
There is, and you don't have to use my checklist, and my checklist covers stations and equipment that you don't even have. So we're going to go over that, and we'll say, well, this one doesn't count for you, or this one does, and I'll show you how to, just a basic rundown how to do it. I got all the covers off, so like for winterizing is another section, and we're just going to do a quick thing so that make sure that you you know what's involved.